We're going to take a look at EOQ safety stock. The first one we're going to look at is continuous. Continuous meaning that inventory will carry over from one period to the next. All right, we have their given information, our annual demand, our lead time, and we're given that the work days are 250 days annually. Again, this basically saying we're working Monday through Friday, and we have your typical 11 holidays off, so that's where we get the 250 from. The first thing we have to calculate is the daily demand. Our capital D is our annual demand, the small d is the daily demand. So all we do is take our yearly demand, we divide it by our work days, which gives us 441.6. And then what we're trying to find out with safety stock is, we're working with our reorder point. And our reorder point is our daily demand times our lead time. We're given the lead time as 5 days. So our reorder point is 208 units. Other words, when our inventory drops down to 208 units, it is time to reorder. For this question, we're giving two other pieces of information. That Mr. Jaggers wants to keep a safety stock at 20 units for problem A, and our service level policy is 92% for problem part B of the problem. Okay, for part A, where we're going to begin with is we have to calculate what's known as a z-score. Just to explain what's going on, is when we do this, we use our X bar, we use that equal to our reorder point. Other words, if our average, if our X bar is our reorder point, 208 units, that means 50% of the time we're going to be out of stock, 50% of the time we're going to have too much inventory. So it's a balancing act to see where's our optimal point. Our service level policy kind of gives us what we can do to guarantee a fulfillment rate for our customers. So with that, we can calculate a z-score. It's basically our X sub I, and we know that we were given in this problem, we just calculated the reorder point of 208. We know that Mr. Jaggers wants to keep 20 extra units here, so 208 plus 228 is 228, which is our safety stock. So this is basically our safety stock, and we're given a standard deviation of 20, and this comes out to 1.25. All right, so with that, what we're really working with the z-scores is this chart here, which is the standard normal bell-shaped curve. What that means is you have your normal distribution, and standard means that the center point is set to 0. You notice that the charts that go along with this go from 0 to 3, so they only go the positive amount. Our 1.25 is basically right here. It's saying that we have 1.25 standard deviations, and what we're looking to do is calculate what correlates with the area under the curve there. That percentage, or the area under the curve, will be our service level policy. So when we do both of them, we get where we want to be. Okay, if you look at the Z chart that just flashed up on your screen, we should see that this is from the z-score. This is how we find the service level policy. We have 1.2 over on this side, 0.05 at the top. Together they make 1.025. Where those two intersect, it comes out with 89.44. Turning that into a percentage, that gives us 89.44%. The calculation is kind of difficult and beyond this course, so that's why we use the Z table. Actually, with modern advances like Excel, you could get the same results from Excel. Although we're not really using Excel in this class, I just wanted to introduce it. You could use the standardized function. And it asks you for your x sub 1, your mean, and your standard deviation, and that comes out with 1.25, which agrees with our hand calculation here. And then the command in Excel to get the service level policy is norms dist, that's what I call it. You stick the 1.25 in there, and you see within a round off error, it gives us the exact same service level policy. For the second part of the problem, where we were given that the service level policy is 92%, we basically do the same thing in reverse. I just simplified it by solving the z-score equation for x sub I, brought everything over to the other side, so I have x1 equals my z times standard deviation plus the average. Looking at the chart for 92% or 0.92 gives me 1.4 here, 0.01 on the top. Look at your chart, you'll see what I mean. So plugging it into the equation, 1.41 times 16 plus 208 gives me an x sub I of 230 units, which makes sense, because if you look compared to where we found the previous xi at 89%, you would expect 92% to be a little greater, and it is. And also you'd expect there to be more area under the curve, and if you look at 1.4 compared to 1.25, again, we do have more area under the curve. So our two answers are, for A, with the safety stock at 20 units, we have an 89.44% service level policy, and for part B, when we're given a 92% service level policy, we need to keep 230.56 units in stock. In real life, you'd probably round this up to 231 units because it's hard to have a half a unit in stock.